Hi, linear algebra students. This is the last example we will do about matrix subspaces. So so first of all, this is a very important concept. The trace of a matrix A is the sum of its diagonal elements. Okay, so I give you an example. If A is 3 by 3, then the trace will be just like the number A11 plus A22 plus A33. And the problem is this. We are given this subspace, the set of all 2 by 2 matrices for which the trace is 0. And you don't have to prove that it's a subspace. I'm telling you that it is, but I'm asking you to find a basis for it. Okay? So the way it works is you're going to say, as usual, you're going to write a condition for a matrix A, let's say, to be in S. So A is in S if and only if then the trace of A is equal to 0. Okay, so the trace of A is, or actually, let's put it this way. So A is 2 by 2, meaning that we have A11, A12, A21, A22, and right. So you need this condition, but also this condition that trace of A, which is A11 plus A22, is equal to 0. Okay, and you are given one equation, and it turns out, of course, that it's linear. Okay, so what you're gonna do is you're gonna have here the equation. So you're gonna have here like A11 plus A22. So actually, let's work here. Actually, A11 plus A2 plus 0 A12. That's what I want to write. I want to actually write all of the variables. 0 A12 plus 0 A21 plus A22, which is equal to 0. And maybe I'm being a little bit like weird over here, but I'm gonna write out a matrix, right? I'm gonna write 1 0 0 1 slash 0. The idea is I just want to write the solution set, right? And keep in mind here that the solution set will be the coordinate vector, but so you can write the solution set as being, or actually, let's actually do it here. Okay, so if and only if A, which is A11, A12, A21, A22, is equal to, and now we're going to write the solution set, but we're not going to write it as a vector, right? We're going to write it as a matrix. So here we go. We have one pivot, so the only one basic variable is A11, which means that we have 3 parameters. Let's color code them. So this will be R, let's say. We will have S, and we will have T. So let's have the T in black. Okay. So when we read a basic variable, we read the row. We have 0R, 0S, and negative T. So let's actually put it here. And then the rest are all free variables. So in other words, you have R, S, and T. Okay. And now, obviously, the next step is to split this as a linear combination, right? Because you want to find a basis. So you want to find matrices that span these matrices A. So this is easy to do, right? Begin with R. R is only in the second N3, so you're having like 0, 1, 0, 0. Okay, plus S. So here I'm only going in alphabetical order. and there you have a 1 here and a 0 elsewhere. And finally, plus t, okay? And you have -1 here and 1 here. So -1, 1, 0, 0. And exactly like our solution set for the null space of a matrix, this is linearly independent by construction. Okay, so actually, let's take note of that. The set of all these matrices. Okay, so let's actually write like 0, 1, 0, 0. Then you have like 0, 0, 1, 0. And finally, -1, 0, 0, 1. Okay, is Li by construction. Remember, the reason why you're allowed to say this, that it's Li by constructions, it's because it's the solution set of like these letters are all the solution set of like one linear equation. So like that's it. These things right here will always be linearly independent in that scenario. So here, let's actually be more precise here. Since solution set. Constructed from augmented matrix. Let's put it this way. From augmented matrix. But then there's more. You also know that they span S, okay? And span S, okay? And the reason why you know that it's span S is because A is in S. Okay, let's actually put it down here. A is in S if and only if A is a linear combination of these three matrices. So we've got our answer. This is it. Unfortunately, I need to erase some part of the problem. So I'll erase this to finish. So we can conclude from there that what we found is actually a basis. So 0, 1, 0, 0. Then 0, 0, 1, 0. And finally, -1, 0, 0, 1. This is a basis for S. All right, I hope this was helpful. See you either in class or in the next video.